In this video, we will solve O-Level Mathematics Paper 1, October-November 2016, and this is the first variant of the paper. So let's start with question number 1 here. So evaluate 3 whole 1 by 6 minus 2 whole 3 by 5. So let's first convert these into improper fractions. So 6 times 3 is 18, 18 plus 1 is 19. So this becomes 19 by 6 minus 5 twos are 10 plus 3, 13 by 5. And then if you take the LCM, which is 30, so 19 times 5 would be 45, 4 carry 95, so the numerator becomes 95. And then 13 times 6 would be 6 threes are 18, 1 carry 78. And then 95 minus 78 will be 17. So you get 17 over 30. Oh, let me write it cleanly. So this is 17 over 30. Part B is evaluate 0.03 into 0.11. So it's always a good idea to convert these decimals into fractions. That makes the multiplication a little bit easier. So if I have to convert this into a fraction, I have to move this decimal 2 places to the right. So this becomes 3 over 100. And similarly, this becomes 11 over 100. And then 11 times 3 is 33. And this is 4 zeros. That means it's 10,000. And then I can divide this 33 by 10,000 by moving the decimal 4 places to the left. 1, 2, 3, 4. So I'll get 0.0033. So this will be your answer here. Question 2 is the paper on a roll is 4.5 meters long. Mary cuts as many pieces as possible, each of length 60 meter from the roll. Calculate the number of pieces. So let's say if you open up the roll, you get this long sheet and you're told that the roll is 4.5 meters long. So this is 4.5 meters, which is also equal to 450 centimeters. So this is this length here. And each length, like each piece that she cuts has a length of 60 centimeters. So if you mark these like here, so each of these is 60 centimeter. So we have to calculate the number of pieces she can cut from this roll such that each piece has length of 60. So that means we have to divide 450 by 60. So you get 60 times 7 is 420. You get 30. So now if I divide further, I'll have to go into decimal. But since we are looking for the whole number of pieces that she can cut, given that each piece has length 60 centimeter, we can only cut 7 pieces. The remaining length is 30, but since the size of each piece is 60 centimeter, we cannot cut another piece from the remaining length. So your answer here will be 7. Calculate the length of paper that remains on the roll. So if you cut 7 pieces, that means you have removed 420 centimeters. So the remaining length is given by the remainder here, which is 30 centimeters. So you will get 7 pieces, each of length 60 centimeters, and then you are left with 30 centimeters of length on the roll. So question 3 is express 32.5% as a fraction. So to convert this, so 32, I can write this half as 0.5, 32.5%. So that is equals to 32.5 over 100. Since we have to represent this as a fraction, I have to move this decimal 1 place to the right. I cannot have any decimal in my values. So this becomes 325. Since I moved this to the right, I will have to divide by 10. So 100 times 10 in the denominator will become 1000. And then we can simplify this fraction because we have to write it in its simplest form. So both are divisible by 5. 5 times 6 is 30, 225. This is 200. I can again divide by 5, which gives me 5 ones are 5, 13, and then 40 here. So this is 13 over 40. Part B is arrange these values in order of size starting with the smallest. So you have a mixture of decimals and these fractions, and we have to sort them from smallest to largest. So the best way to do this would be to convert these two fractions into decimal as well. The other way would be to convert these decimals into fractions, but then you'll have to take LCM of all four, and that can take a long time. So let's convert these two fractions into decimals. So 9 divided by 25. So this will be 0 point. I'll have to add a decimal here. So 0. So 90 means 25 times 3 is 75. I get 10 minus 5 and then 15. I add another 0, bring it down, 150. And 25 times 6 is 150. So you get 0. So this is 0 0.36. And then 7 divided by 20 as well. So 0 0.0, 20 times 3 is, this is 360. 0, 1, and then another 0. This becomes 100, and 20 times 5 is 100. So 7 by 20 is 0 0.35. Now it becomes really easy to sort them from smallest to largest. So if you look at these values, 0 0.35 is the smallest, so that is represented by 7 over 20. The next biggest value is 0 0.36, which is 9 over 25. Next value is 0 0.38, and then 0 0.4. Question number 4 is 1 kilogram of tea costs $16. Calculate the cost of 300 grams of tea. So 1 kilogram in grams would be 1000 grams. So 1000 gram is ratio 16, and then you have to find the, so 300 gram would be value x. So you can solve this, cross multiply like this and like this. You get an equation 1000x equals to 16 into 300, and then x equals to 16 into 300 divided by 1000. So these two zeros cancel off. 16 times 3 is 48, divided by 10, which is equals to $4.8. So your answer would be 4.8. So you can also use the unitary method. You have, you know that the cost of 1000 kilogram is $16. So cost of 1 gram would be 16 by 1000, right? And then cost of 300 gram would be 16 by 1000 into 300, which will give you the exact same answer. So if you want to use the ratios or the unitary method to get the value of 1 gram first and then 300 gram, both are fine. Part B is find the simple interest on $400 for 3 years at 2% per annum. So this is simple interest, and you know that simple interest is given by PRT over 100, where P is your principal amount, R is the rate, and T is the time in years. So principal is 400, rate is 2% into 2, and then time is 3 years, so 3 over 100. These zeros cancel out. 4 times 2 is 8, 8 times 3 is 24. So $24 is the interest on $400 for 3 years at a 2% rate. Question number 5 is write the number 357.864 correct to two significant figures. So if you start from the left, this would be your first significant figure, this would be your second significant figure. So you have to round it up till here. So the next value is 7, which is greater than, so 5 or greater than 5. So you will round it, so you'll round this 5 up to 6. So you get 360. So your answer would be 360. Part B is estimate correct to the nearest whole number the value of cube root of 67 divided by 1.03. So since you have to estimate, you can check the closest cube that is closest to 67 so that you get a whole number here. So 67 cube, you can actually write it, estimate it as cube root of 64 because we know that this is a whole number. Cube root of 64 is 4. And then you can also estimate the denominator. 1.03 can be written as 1. So cube root of 64 will give you 4 over 1, which is 4. Question 6 is y is inversely proportional to x. So y is inversely proportional to x. So y is equals to k over x. Given that y equals to minus 50 when x equals to 3. So y is minus 50 when x equals to 3. So k is negative 150. Find y when x equals to minus 10. So y is equals to k over x, and then you have k as minus 150 here, and then x is given as negative 10. So negative negative cancel out, zeros cancel out, and you get y equals to 15. Let's move on to question number 7 here. Each interior angle of a regular polygon is 171 degrees. Find the number of sides of the polygon. So you're given that there's a polygon. It's a regular polygon, which means all the angles are equal. And the value of each angle is 171 degrees. So you know that the sum of angles of a polygon is given by n minus 2 into 180. That gives you the sum of all the angles of any polygon with sides n. And since you are given that each angle is 171, I can actually equate it to 171 times n, right? So there are n sides and each angle is 171 degrees. So the total sum of all the angles would be 171 times n. And then you also have this formula n minus 2 into 180. So these two should be equal. So we can use this equation to calculate n, which is the number of sides which we want here. So if I open up the brackets, I get 180n minus 360 equals to 171n. If I bring this here and this to the other side, I get 180n minus 171n equals to 360. 9n equals to 360, and then n equals to 40. So your number of sides of your polygon is 40. Question number 8 is, part A is 2 cube. You have to evaluate the value of 2 cube minus 2 to the power 0. So 2 cube is 2 times 2, 4, 4 times 2, 8. And then anything power 0 is 1. So this is 8 minus 1, which is 7. So this gives you 7. Part B is simplified 12xy over 9x squared. So you have 12xy over 9x squared. So I can divide both the numerator and denominator by 3. So 3 times 3 is 9, 3 times 4 is 12. I can also cancel this x, and this x squared in the denominator becomes x power 1. So this is equals to, I only have 4 and y on in the numerator, and in the denominator I get 3x. So your answer is 4y over 3x. Question 9 is, the cumulative frequency graph shows information about the reaction times of 60 people. So you have the cumulative frequency curve here. Use the graph to estimate the lower quartile. So the lower quartile is the 25th percent value, which can also be written as 25 by 100, which is 1 over 4. So if you take 1/4 of 60, so you get 1 by 4 into 60, and 4 times 1, 4 times 1 is 4 to 20, 15. So your 15th value would be your lower quartile. So let's look at this graph to calculate the 15th value. So this is 0, 10, so this is 20. That means, so 5 boxes in between 10 and 20. So that means each small box represents 2. So this would be 12, this would be 14, and this one will be 15 here in the middle. So it's in the middle of this small box. And trying my best to draw the straight line in the middle here. If you keep going and see the intersection of the graph, so this is the point where you intersect with this curve in the middle of this square, and then you come down here. So you will end up one small box to the right of 0.15. So now we need to know what value one small box represents. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boxes between 0.2 and 0.15. So your difference is 0.05. So the change in value is 0.05 between these 2 points. And then there are 10 boxes in between. So one box will represent 0.05 divided by 10, which is 0.005. So each small box on the x-axis represents a value of 0.005. So since I am one small box to the right of 0.15, my 15th value from this graph would be 0.15 plus 0.005, which is equals to 0.155. So your answer would be 0.155. Part B is the number of people who have a reaction time of more than 0.2 seconds. So we have to find the number of people whose reaction time was more than 0.2 seconds. So if you look on the x-axis, this is 0.2. And if you look at the y value, which is 40 here, so 40 people have a reaction time of up to 0.2 seconds. There are some people who have less, but when you reach 0.2, your cumulative frequency is 40. That means 40 people out of the 60 have a reaction time of at most 0.2. That means 0.2 or less. But we have to calculate the reaction time of more than 0.2. So that means if your total number of people is 60 and number of people with a reaction time of 0.2 here, this here is 40. So the remaining people have a reaction time of more than 0.2. So this is greater than 0.2 and this is the rest of the people. So 60 minus 40 is 20. So 20 people have a reaction time of more than 0.2 seconds. Question 10 is write the number this given in standard form. So standard form means that you have to place your decimal here between 4 and 5. So that will become 4.5. So if right now my decimal is here, so I have to move it 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So since I'm moving the decimal 8 places to the left, I will multiply it by 10 to the power positive 8. So my answer would be 4.5 into 10 power 8. Again, part B is giving your answer in standard form. Evaluate this expression. So I can remove this decimal here so that I make this division easy. So it becomes 15 into 10 to the power. So since I move the decimal one place to the right, I'll decrease the power by 1 of this 10 here. So that becomes 10 power 4. And then divide by 5 into 10 power minus 5. So I can easily cancel these out. 5 times 1 is 5, 5 times 3 is 15. And then since I'm dividing these two, I will subtract their power. So this becomes 3. This would be equal to 3 into 10 to the power. In the numerator, I have 4, and then I'm subtracting the power in the denominator here. So 4 minus 5. This minus minus becomes plus. 5 plus 4 is 9. So you get 3 into 10 power 9. So 3 into 10 power 9. Let's move on to question number 11. So part A is evaluate f of minus 1 by 2. So you will simply substitute x with minus 1 by 2 here. So f of x would be 3 minus and then minus 1 over 2 whole divided by 10. This minus minus becomes plus. So this becomes 3 plus 1 over 2 divided by 10. I can convert this easily into a decimal. So this is 3 plus 0.5 divided by 10. Then this is 3.5 divided by 10. And then since it's being divided by 10, I can move the decimal one place to the left right here. So this will become 0.35. So your answer would be 0.35. Part B is you have to find f inverse of x. So to find that, we let y equals to f of x, and this gives you, if I take f on the other side, this becomes f inverse of y equals to x. So let's start with this. Y equals to f of x, I can replace the value of f of x here, which is 3 minus x over 10. And now if I make x the subject of this equation, I can get the value of f inverse of y, because f inverse of y is equals to x. So to do that, to make x the subject of this equation here, I take 10 to the other side. So this becomes 10y equals to 3 minus x. And then I can take this 3 to the other side as well. So this becomes 10y minus 3 equals to minus x. And then I can multiply it by minus 1 on both sides. So I get positive x equals to 3 minus 10y. And then you know that x is equals to f inverse of y. So f inverse of y equals to 3 minus 10y. And from this, if I substitute x here, I can write x here as well. So you get f inverse of x equals to 3 minus 10x. So your f inverse of x here is 3 minus 10x. Question 12 is you're given a universal set of these numbers. Is a set of numbers from these that are even. Q is a set of numbers from these that are multiple of 3. So you have to find the number of elements in P union Q. So you have to find all the elements that are even or multiples of 3. So we can start from the first one here. 84 is even. 8 plus 4 is 12. So this is also divisible by 3, but you do not, in a union, you do not count the same element twice. So if you have included it once, you cannot include it again. So 84 is even, we have already included it. 85 is odd, and you can check the divisibility by 3 by adding 8 and 5, which is 13, the sum of 8 plus 5. And then 13 is not divisible by 3, so 85 won't be divisible by 3 as well. This is an even number. 8 plus 7 is 15. 15 is divisible by 3, so this is also part of our union. This is even, so we don't need to worry to check if this is multiple of 3. So we can, in fact, mark all the even numbers that we know are part of the union. So 89, 8 plus 9 is 17, not divisible by 3. 9 plus 1, 10 is not divisible by 3. 9 plus 3 is 12. 12 is divisible by 3, so 93 will be divisible by 3 as well. Then 9 plus 5 is 14, and 14 is not divisible by 3. So these are the numbers that will be part of P union Q. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So your answer would be 9. Given that y belongs to this set and that y is a prime number, write down the value of y. So you have to find the prime numbers. In fact, a single prime number from this set. So we can cancel out all the even numbers, right? Because we know they are divisible by 2, so they can't be prime numbers. So, and we can also cancel out the multiples of 3, 8 plus 5, 13. So this is not a multiple of 3, but this is a multiple of 5 since you have 5 here in the unit place. So this can be divisible by 5, so this is not a prime number. 87 is 8 plus 7, 15. So 15 is divisible by 3. So this is divisible by 3. This cannot be your prime number. 9 plus 1 is 10. So this could be your candidate for the prime number. So we can check it later on. Let's move on to the next one. 9 plus 3 is 12. So this is divisible by 3. And Oh, sorry, I missed 89 here. So 89 is 8 plus 9, 17. So this could be your candidate as well, because right off you cannot say that this is divisible by any number. So we can check these two. So let's cancel out that we are pretty sure that are not prime. So 95 is also not prime since this is divisible by 5. So you're left with 89 and 91. So let's start with 91 first. So 91 is not divisible by 2. It's not divisible by 3. This is also not divisible by 4 since this is not even. Not divisible by 5 since you don't have a 5 or 0. Not divisible by 6. You don't have a even number here. By 7. Let's see if it's divisible by 7. 7 times 1 is 7. 9 minus 7 is 2. And then 21. And 7 times 3 is 21. So this is divisible by 7. So that leaves you with 89, the last number. And if you check starting from 2, 3, 4, 5, 6, 7, there's no number that can divide 89 such that the remainder is 0. So 89 would be your answer. This is your prime number that is part of this set. So 89. In the Venn diagram, shade the region represented by A complement intersection of B. So let's start on the left side here. So what is A complement? A complement is everything outside of A. So let me shade A complement in red here. So everything outside of A here is A complement. And what is B? B is this green one. So you have to find the intersection of the two. A complement, red one, intersection B, this green one. So which part is both shaded red and green, which represents this intersection? It's this part here. This part is both shaded red as well as green. So this represents A complement intersection of B. So let me just erase this and mark the actual region that we need. So this would be your A complement intersection B. Question 13. During one day, the temperature in degrees Celsius was recorded every 2 hours. The 12 results are given below. For these results, find the median. So you're given these values, and straight away you can notice that these are not sorted. So for median, you have to sort these values from smallest to largest. And then since how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. So your median would be 12 divided by 2, which is 6. Since you have even number of values, your median would be sixth value, and then you take plus 1, which is the seventh value, and then you divide by, so you add them together and then divide by 2. So to get the sixth and seventh value, you first have to write them in ascending order, starting with the smallest value. So your smallest is minus 3 here. Yep, and then you have minus 2. How many times? 1, 2, 3. So you have 3 minus 2's, minus 2. And then you have minus 1, 0, 1, 2 twos, so 2, 2, and then 4, 4, 4, 4, and then 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have written all the values, all 12 values. So let's see what's the sixth and seventh value. So 1, 2, 3, 4, 5, sixth. So this is the sixth and this is the seventh value. So that will be 0 plus 1 divided by 2, which is 1 over 2, which is 0.5. So your answer is 0.5 degrees Celsius. Then you have to find the mean value. So mean would be sum divided by total number of values. So sum, we can add them all together. So -3. So I won't write all the values. I'll just calculate the sum up here. So -3, -2, -5, -7, -9, -10. Same 10, -10 plus 1 is -9, then -7, -5, -1, 3, and 8. So you have the sum is 8 and you have 12 values. So I can divide this. I can take 4 common. So 4 times 2 is 8, 4 times 3 is 12. So you get 2 by 3 median in the simplest form here. So this is 2 by 3. Or if you want to write it as a decimal, you can do that as well. Part C is the difference between the highest and lowest of these temperatures. So difference would be, so you have to find the difference between the highest and lowest of these temperatures. So what's the highest value? So that will be highest minus the lowest. So your highest value here is 5, and then your lowest value is -3. So -3, so minus minus becomes plus, 5 plus 3 is 8. So your answer would be 8. So let's move on to the next question. So question 14 is, in the diagram, triangles APQ and ABC are similar. So this is APQ here, and then ABC is this big triangle. And then you're given BC is parallel to PQ. So BC is parallel to PQ, and AP is 4, PB is 2, PQ is 1.8. Find BC. So since this big triangle, let me mark this. Oops. So this triangle ABC, and this one here in green, this one right here, these two are similar. So to find BC, I can use uh, the property that the ratio of the lengths of two similar triangles is same. So, but you have to, the ratio of the corresponding length. So if you take AP here, and then your corresponding length would be AB for the other triangle. So AP is this, which is 4, and then your AB is this length, which is 4 plus 2. So 4 over 6 should be equal to, so since we are looking for BC, so BC is this length, and the corresponding length for in the triangle APQ is PQ. So PQ is this, so 1.8 over BC. And then we can solve this. You get 4BC equals to 1.8 into 6, and then BC would be equals to 1.8 into 6 divided by 4. I can take I can divide by 2 here, and then this becomes 3. So 1.8 times 3 would be, let's see, 1.8 times 3 would be 24 to 5.4. So 5.4 divided by 2, and this would be 2 times 2 is 4, 114, 2.7. So 2.7 centimeter. Part B is, find area of triangle APQ over area of quadrilateral PBCQ. So now you're looking for APQ. APQ is this green one. And then let me mark this in red here, this quadrilateral here. So now you have to find the ratio of the area of this green triangle over the area of this red quadrilateral. So we can again use the property of similar triangles. So if I have, And I know that I can find the area of this quadrilateral if I subtract the area of this green triangle APQ. If I subtract this area from this big triangle ABC, I'll get this remaining area, which is the quadrilateral. So using the property that's the area of the ratio of area of similar triangles is equal to the square of the ratio of the lengths, corresponding lengths. So let's say area of APQ triangle over area of triangle ABC. So APQ, area of triangle. So I can use these two sides again, AP and AB, the two corresponding sides of the two similar triangles. So AP is 4, and then AB is 6, and then whole squared, since we are taking the ratio of the areas. So this becomes equals to 16 over 36, and then I can divide this by 4. 4 fours are 16, 4 nines are 36. So you get 4 by 9. So area of triangle APQ is 4, and then area of triangle ABC is 9. Now, if I want to calculate this ratio here, area of triangle APQ over area of this quadrilateral PBCQ, then I know this is 4, and PBCQ is this 9, which is the area of this whole triangle minus this green one, and this green one is in the numerator, so APQ, so 9 minus 4, which will be equal to 4 over 5. So your answer would be 4 over 5. Question number 15 is describe the single transformation that maps triangle A onto triangle B. So you have these two triangles here, and by looking at it, it seems like this is a rotation of 90 degrees in anti-clockwise direction, because this triangle is now rotated like this and rotated by 90 degrees. Uh, so the best way to solve these problems are to actually use your compass and your ruler to find the center of rotation, and then find the angle of rotation as well as whether it's clockwise or anti-clockwise. So to find the center of rotation, what you can do is you can, so let's start with marking the corresponding point. So let's say if this is PQR, so in the triangle B, this is P1, P prime, Q prime, and R prime. So these are the corresponding points. P is mapped onto P prime, Q is mapped onto Q prime, and R is mapped onto R prime. So let's let's join these 2 points. So if this is P, and let's connect it to its corresponding map point, which is P prime, and then let's map R to R prime. So you only need 2 pairs. So we already have 2 pairs, P prime and Q, oh sorry, R and R prime. So now to find the center of rotation, you have to draw the perpendicular line bisector of these lines, P prime, R prime, and the intersection of those two line bisectors will give you the center of rotation. So let's first draw the perpendicular line bisector for line P prime. So if I place it at P here, and then I have to open it up more than halfway. So this is more than half the length of this line. And then I can draw the corresponding arcs here. So this is my first arc here. And then I can draw the other one here. And then I place it on P prime. And then I can draw the arcs here. And then also here. And similarly, so let's first draw this perpendicular bisector of P and P prime. So this would give me the perpendicular bisector here of P and P prime. So now let's also draw the perpendicular line bisector of this line R and R prime. So again, I open it up to more than halfway. It's already good. So let's draw these arc here. So I'll get one arc here and then one arc here. And then I place it on R and then draw the arcs again here and this one here. So this is your point here. I know it's kind of overlapping with the other arcs, but this is the point here, and then this is the other one here. So let's join these two to get the line bisector for R and R prime. So now you have drawn the two line bisectors. So this is your point of intersection right here. So this point is 3 on x-axis and y-axis is value is 1. So let me, so now you have the center of rotation, right? So let's clean it up a little bit. So here I have now cleaned up the line bisectors and we found out that this point 3, 1 is our center of rotation. Now to calculate the angle of rotation, what you can do is simply connect any two corresponding points from triangle A and B and see what's the angle between the two lines. So let's say I take this point Q, let's connect this to the center of rotation, and then I take Q prime and connect this to the center of rotation. So I know that this makes a 90-degree angle. So this Q went 90-degree in this direction, right? It was here and then it moved 90-degree in this direction. So you know that this is clockwise. So your transformation is 90-degree clockwise with center that you calculated is 3 and 1. So this would be your two marks. One mark for the angle and direction and the other one for the center, the coordinates of the center of rotation. So part B is triangle A is mapped onto triangle C by an enlargement with center 0, 2 and scale factor -2. Draw and label the triangle C on the diagram. So your center of enlargement is 0, 2, which is this point here. Let's label it O. And let's label the vertices again for triangle A, which is P, Q, R. So triangle A is P, Q, R. And then triangle C, after an enlargement, let's call it P1. Sorry, this is P1, Q1, and R1. So to map this point P onto P1, what we do is so one method is connect each point with the center of enlargement. So this line connecting O and P, OP, and then measure the length. So if I measure this length here, this is almost 1.7 centimeter of line OP. And then line OP1 would be twice because your scaling factor is 2. And since there's a negative sign, point P1 would be on the opposite side of the center of enlargement. So if this is OP is 1.7 centimeter, then my length OP1 would be double, which is 3.4. So I can place this here at 3.4. So my 0 is here. So my point OP1, which has double the length and on the opposite side of the center of enlargement, P would be here at -2 and 4. But there's another method to do this enlargement without using these measurements, because sometimes these measurements will be in decimals and it can get difficult to find the exact orientation of your ruler and then measuring the length. So an easier method to do this is we can write each point, the coordinates of each point PQR relative to this center of enlargement. So similar to how you write column vectors, the XY coordinates like this. So my point P can be written as, if I start, so this would be my origin. Always your center of enlargement would become your origin. So you have to find the coordinates of point P relative to center here. So you move 1 point to the right, which is +1 in X, and then -1 in Y to get to P. So +1 in X and then -1 in Y to get to P. So let's write for Q as well. So Q is +2 in X and -1 in Y. And then R would be +2 in X and +1 in Y. So +2 in X and +1 in Y. And then to find P1, you just simply have to multiply this column vector with your scaling factor. So P1 would be P, which is 1 minus 1, multiplied by your scaling factor, which is -2. So you get -2 and then +2. Similarly for Q1 would be 2 minus 1 multiplied by -2. So this would be -4 and +2. And then your R1 would be 2, 1 multiplied by -2, your scaling factor, and this becomes -4 and -2. But remember, all these coordinates are with respect to this center of enlargement. So your P1 would be -2 and 2 means you move -2 in X direction from your center and then +2 in Y direction to get to P1. So this would be your point P1. Q1 is -4 and 2. So you move 1, 2, 3, 4, and then +2. You end up here. So this point here is your Q1, and then your R1 is -4, -2. So you move 1, 2, 3, 4, -4, and then -2. You end up here. So this would be your triangle C after the enlargement. So I prefer this method because you simply have to do this quick calculation to get to the points. Sometimes while measuring the lengths using your ruler here, it can become a little bit difficult to get the exact value and get the exact orientation. So this method is pretty simple. You just put XY coordinates relative to your center of enlargement and then multiply by the scaling factor to get the corresponding coordinates after the enlargements. So you can use either method. Both should give you the same answers. So whichever you feel is easier, you can use that method. So question number 12 is you have to factorize these expressions. So the first one is 5 minus 20t squared. So I can take 5 common, and this leaves me 1 minus 4t squared. And I can see that I can further factorize this expression inside using the formula a square minus b square is equals to a plus b into a minus b. So this is basically 1 squared minus, so if you take the square root of this, you get 2t. So this 4t squared can be represented as 2t whole squared, and then this bracket. And so now I have this expression where a is 1 and b is 2t. So I can further factorize it as 5 into 1 minus 2t times 1 plus 2t. So this would be your final answer, 1 plus 2t. Part B is 3y squared minus 2xy minus 6x plus 9y. So I can rearrange these so that I have 3y squared, and I can bring this 9y here. So this becomes plus 9y, and then minus 2xy minus 6x. Now I can take 3y common from these two values. So this becomes 3, oh, sorry. So this becomes, I can take 3y common. This becomes y plus 3. And then I can take 2x common from this. So minus 2x. And this becomes y plus 3, because you have a minus sign here. So this sign will change. So y plus 3. So this, if I open this, I get the same expression. Let me double check. 2 minus 2xy and then minus 6x. So yeah, this is correct. So then I can take y plus 3 common as well, because both of these terms are being multiplied by y plus 3. So this becomes y plus 3 into 3y minus 2x. So this will be y plus 3 into 3y minus 2x. So question number 17 is, in the diagram, the points A, B, C, D, E lie on the circle center O. So this is the circle, and these points A, B, C, D, E all lie on the circumference, and AD is the diameter. Two angles are given, DAC and ACE. You have to find the angle CDA. So you have to find this angle here, CDA. So since this is the diameter, AOD is the diameter, and this diameter is making an angle. So angle ACD here, ACD here. So this angle is actually 90 degrees, because this is an angle in a semicircle, or angle subtended by the diameter on the circumference of the circle. This is always equals to 90. So we know that this is 33, this is 90. So we can add up all the three angles of the triangle, CDA plus 33 plus 90. This should give you 180 degree. So CDA would be equals to 180 minus, so this is 123, and this gives you 180 minus 23 will be 57. So your CDA is 57 degrees. Part B is find angle DEC. So let me just erase this, and let me just mark this angle that we have already calculated. This is 57 degrees. Now you have to find DEC. So DEC is this angle, DEC, this angle here. So you have to find this angle. So if you look at this angle DEC, it is subtended by this arc that I'm marking in red, DC. So let me just mark this angle as well. So this is your angle DEC, right? And it's made by this arc. But if you look at this angle here that I'm marking in green, CAD here, this is also subtended by the same arc DC. So using the property that these angles are subtended by the same arc on the circumference of the circle, so this angle DEC would be equal to the angle CAD. So angle DEC would be equals to this angle here, 33 degrees. Part C is find angle ABC. So ABC here. So let me just erase this that I drew in the previous one. So we know that this angle here is 57 degrees that we calculated in part A. And now we have to calculate this angle ABC. So if you look at this quadrilateral ABCD, this is actually a cyclic quadrilateral because all four vertices are on the circumference of this circle. So we can use the property that the sum of the opposite angles of the cyclic quadrilateral is 180 degrees. So ABC plus this angle CDA, which is 57 degrees, should equal 180 degree. So your angle ABC would be 123 degrees. If you subtract 57 from 180, you get 123. So this angle here would be 123 degrees. Part D is find the reflex angle EOA. So this is EOA. So this angle is EOA, but you actually have to calculate this angle here, which is the reflex angle EOA. So this is the one that you need to calculate right from here actually. So all the way from here. So both these, this one, the blue one, and plus this red angle should sum up to 360 degrees. But if you look at this angle EOA, the blue one, right here, and then this one, it is subtended by this arc AE, right? So this angle here, ACE, is also subtended by the same arc here. So if you look at this angle AOE, this should be twice as much as this angle here ACE, because both angles are subtended by the same arc. One is at the center of the circle and the other one is on the circumference. So the one at the center is twice the value of the angle at the circumference. So your angle EOA would be equal to 70 into 2, which is 140 degrees. But since you have to calculate the reflex angle EOA, so your reflex angle EOA should be, this whole angle is 360, but this one is that we have calculated is 140. So that will be 360 minus 140, which is equals to 220 degrees. So your reflex angle EOA would be 220 degrees. Let's move on to the next question. Question number 18 is you have to solve these simultaneous equations. 2x plus 5y equals to 2 and 3x plus 4y equals to minus 4. So I can use the substitution method. So let's call this equation 1, this 2. So from 1, I can get, so 1 is 2x plus 5y equals to 2. 2x becomes equals to 2 minus 5y, and then x equals to 2 minus 5y over 2. And then I can put this x in 2. So equation 2 is 3x plus 4y equals to minus 4. I can substitute the value of x here. So 3 times 2 minus 5y over 2, and then plus 4y equals to minus 4. Now if I open these brackets up, I get 6 minus 15y over 2 plus 4y equals to minus 4. If I take the LCM, let me just continue up here. So if I take the LCM here, this becomes 6 minus 15y plus 8y over 2 equals to minus 4. So minus 15y plus 8y would give me minus 7y. So 6 minus 7y over 2 equals to minus 4. I can take the 2 to the other side. Minus 7y becomes, 6 minus 7y becomes equals to minus 8. And then if I take this 6 to the other side, I get minus 7y equals to minus 8. And then minus 6 will become minus 14. And y will be equals to 2. And then I can use this value of y and substitute here to get the value of x. So x is given by 2 minus 5y. So y is 2, and then whole divided by 2. So this gives me x equals to 2 minus 10 over 2, which is equals to 2 minus 10 is minus 8 over 2, which gives me minus 4. So your value of x is minus 4 and your value of y is 2. So question 19 is the diagram shows the points O and R and the vectors A and B. Part A is given that OP is equals to 2A. Mark and label the position of P on the grid. So I can write this vector A as a column vector. So A can be written as, if O is my origin, so I move in negative x direction, minus 1. So my column vector for A would be minus 1, and then I move minus 2 in, I move 2 in the negative y direction. So this is minus 2 here. So my vector A can be represented as a column vector as minus 1 and minus 2. So your OP is given as 2A. So your OP would be 2 times A. So minus 1 minus 2, which gives me minus 2 and minus 4. So now I can easily mark the point P because I know its position vector is minus 2, minus 4. So I have to start from O, move 2 places to the left because of minus 2 in the x direction. So I go minus 2 here, and then I have to go down minus 4 places since there's minus 4 in the column vector. So 1, 2, 3, 4. Oh, let me actually do it again. So this will be right down here 4 places. So you will end up at this point. So this point here will be your point P, which is equals to 2 times the vector A. The next part is, given that OQ equals to 2B minus A, mark and label the position Q on the grid. So I can, similar to how I wrote A as a column vector, I can write B as a column vector as well. So B would be, so since from if I start from O, I move 2 places to the right in positive X. So I get 2 in this direction, positive. And then since I don't move up or down, so on the Y axis, Y value would be 0. So this is my vector B as a column vector. So my OQ is 2B minus A. So 2 times B would be 2 times 2, 0, and then minus A would be minus 1, minus 2. So this becomes 4, 0, and then minus 1, minus 2. So 4 minus minus becomes plus. This is equals to 5 and then 2. So my position vector for OQ, so for position vector for Q is 5, 2 from origin O. So I can move 5 places to the right. So 1, 2. So let's move in this direction. 1, 2, 3, 4, 5. And then I have to move 2 places up. So that will be 1, 2. So this would be my point Q here. So this would be Q. Part C is express OR in terms of A and B. So I can, so this was part A, this was part B. Let me solve part C up here. So part C is express OR in terms of A and B. So I can write OR equals to some constant times vector A. And let's call that constant M. So this is vector A here. Vector A plus n some other constant times vector B. So now if we can find the values of m and n, then I can find the vector OR in terms of A and B. So if I know that this point is given here as R, so if I look at this R, I can represent this position vector of point R in a column vector. So I move 3 places to the left. So this is -3 here. And then I move 2 places up, which is +2. So my OR can be written as -3 and then +2 on the Y. And this is equals to M times A. A is what? I calculated A here, which was -1 and -2. And then N times B. So B is what? 2 and 0. So this is 2 and 0 here. So now I can solve for m and n because I can form two equations. So if I look at the x values, I get -3 equals to -m plus 2n. And then if I look at the y values, I get 2 equals to -2m plus n times 0 is 0. So this would be 0. So this is my first equation. And oops, let me write it this cleanly. So this is m here, and this is the second equation here. So from the second equation, 2 is equals to -2m, I can actually calculate the value of m. So let's say from 2, I get -2m equals to 2, and then m equals to -1. So let me just partition it so I can continue here. So my m is -1. And then I can substitute the value of m in equation 1. So I get -3, and then -m is -1 plus 2n. So this becomes +1, which I take to the other side. And then this becomes -4 equals, -4. Let me erase this. -4 equals to 2n, and then n equals to minus 2. So now I know the values of m and n. Then I can write OR. So let me just write it here. OR I know is m times a. So m is minus 1. So minus 1 times a plus n is minus 2 times b. So this becomes minus a minus 2b. So my vector OR can be written as minus a minus 2b if you want to express it in terms of a and b. So your answer would be minus a minus 2b. So question number 20 is the diagram shows a quadrilateral ABCD. Part A is measure the angle DCB. So DCB would be this angle here at vertex C. So let's use our protector to measure this angle. So let me place it at 0 here. Yeah. So if I look at the value here, so this is 125, then 126, 127. So it's almost 127 degrees. So my angle DCB would be 127 degrees. So part B is construct the locus of points inside this quadrilateral that are 8 centimeter from B. So that will be an arc of radius 8 centimeter, but inside this quadrilateral only. So let's use our compass here and open it up till 8 centimeters. So if I place it at 0 here and then open it up till 8 centimeter. So let's place it at point B here, and then my arc will start from this point. Oops, made a mistake. Let me just open it up till 8 again. So it is almost, oops, here. Yeah, this is 8. So place it here at center B. And then since you only have to draw inside this circle, so it will start here and then go all the way up till this line. So you only have to remain inside this quadrilateral ABCD. So the next part is construct the locus of points inside the quadrilateral that are 5 centimeter from AB. So 5 centimeter from AB means that you have to draw a parallel line to AB that is 5 centimeter away and inside this quadrilateral. So I can use my set square. So you have to make sure that you align your set square with this line so that your distance is always perpendicular at a 90-degree angle, since this angle is 90 degree and I am aligned with this line. So now I can place it at 0 and I have to go 5 centimeter away. So 5 centimeter point will be here, right here. So for a line, you'll need 2 points. So I can move my set square again somewhere down here and then place it at 0, and making sure you're always aligned with the line so that you're always calculating a distance at a 90-degree angle. And then my 5 centimeter will be here. So now I have the 2 points that I need to draw my line. So I can use my ruler here to first lets me align the 2 points properly here. Yeah, so let's draw the line, and again you have to remain inside the quadrilateral. So you'll start from this point here and then join them here. So this is your line that is 5 centimeter away from AB. Part 3 is these two loci meet at point P. So this is the point where the two loci, the arc and the line meet. Mark and label the point P on the diagram and measure PD. So since this is your intersection point, so this will be your point P. And then you have to calculate the distance of P from D. So let me use my ruler here again. So this is point P, and then I have to measure till D. So let me place it at 0 here. So the distance is almost 3.4 centimeter here. So my distance PD would be 3.4 centimeter. So that was question number 20. Question 17 is you're given a matrix A and you have to evaluate 3A minus 2 times this matrix here. So we can write 3 times A is 2 minus 1, 1, 3, and then minus 2 times 3, 1, minus 2, 0. So if I bring this 3 in, this becomes 6 minus 3, 3, and 9. And this becomes 2 times 3 is 6, 2 minus 4, and 0. And then if you subtract these two matrices, you get 6 minus 6 is 0, minus 3 minus 2 is minus 5, 3 plus 4 will become 7, and 9 minus 0 will be 9. So you get 0, minus 5, 7, and 9. Part B is find A inverse. So to find A inverse, you need to calculate the determinant. So A inverse is 1 over the determinant of A multiplied by the adjugate of A. So determinant is given by you multiply these two values. So determinant of A would be 2 times 3, and then minus you multiply these two. So minus 1 times minus 1. So this is 6 minus 1, and then minus minus becomes plus. 6 plus 1, 7. And then adjoint of A is you, let me erase the lines that I draw here. So for adjoint, you substitute these values, you swap these values, basically 2 moves here and 3 moves here, and then you change the sign of values here in green. So this one becomes minus 1, this minus 1 becomes positive 1. So your adjugate of A would be equal to, you swap the values, so this becomes 3 and 2, and then you change the signs. So you get 1 and minus 1. So A inverse would be 1 over determinant, 1 over 7 times this adjugate, which is 3, 1, minus 1, and 2. So if you bring 1 by 7 inside, this becomes 3 by 7, 1 by 7, minus 1 by 7, and 2 by 7. So this will be your answer here. So 3 over 7, 1 over 7, minus 1 over 7, and 2 by 7. Part C is write down the single matrix that is equivalent to A inverse times A. So you don't need to actually calculate this. You don't need to multiply A inverse with A to get the answer. You know that when you multiply the inverse of a matrix with the matrix itself, you get the identity matrix, which is 1, 0, 0, 1. So this will be your answer here. Question number 22 is the diagram is the speed time graph of part of a car's journey. Find the speed when t equals to 8. So you have speed on the y-axis, time on the x-axis here. So you're looking to find the speed at t equals to 8, which is somewhere here. And if I extend this line here, oh, let me make sure it's a straight line. So if t equals to 8 is here, so you're looking for the value at this point. You want to calculate the speed. So let's call that speed s. So since this is a straight line, the gradient should be constant, right? If I calculate the gradient of this straight line here, of this part, using any 2 points on this line, I should get the same gradient. So let's find the gradient using this point here, which is uh, 10 and 12, and this point here, which is 0 x value and 4 y coordinate. So gradient would be y2 minus y1, which is 12 minus 4 over x2 minus x1, which is 10 minus 0. So your gradient is 8 over 10, which is 0.8. So I know that gradient is 0.8. Now let's use this point here. So since the x value is 8, so this point here is 8 and the y value is s, so s. So I can write the gradient 0.8 as the y value is s, so s minus 4, over the change in value of x, which is 8 minus 0. So 8 minus 0. So this gives you 0.8 equals to s minus 4 over 8. And this will give you s minus 4 equals to, if I take 8 to the other side, 0.8 multiplied by 8, then s equals to 0.8 multiplied by 8 would be 6.4, and then I take this 4 to the other side, so this becomes plus 4, and then I get s equals to 10.4. So your speed here at t equals to 8 seconds is 10.4 meters per second. Part B is find the distance traveled by the car from t equals to 0 till t equals to 10. So let me clean this out. So now you're looking to find the distance traveled by the car from t equals to 0 till t equals to 10. So if you look at this shape, this is actually a trapezium. So we can find the area under the speed time graph to get the distance. So distance would be equals to the area of the trapezium, which is given by 1 by 2 into the height is 10 here. This is the height. So height is 10 and then multiplied by the sum of the parallel sides. So one side is 4 here plus the other side is 12 here. So 12. So you get 4 plus 12 is 16. 16 times 10 is 160 over 2, which is 80. So 80 meters. So the distance traveled from t is equals to 0 till t equals to 10 is 80 meters. So let's move on to the next part, which is on the diagram below, sketch the distance time graph from t is equals to 0 till t equals to 15. So we already know that in the first 10 seconds from t equals to 0 till 10, the distance traveled is 80 meters. So at t equals to 10, you will have a point here on the graph, which is uh, at 80 meters. So let me actually just put a dot here so that once I draw the graph, it does not interfere with the graph. So I know that at 10 seconds, the distance traveled is 8. I can also calculate the distance traveled till t is equals to 15 if I just calculate this area as well. So let's say distance traveled from t equals to 10 till t equals to 15. From t equals to 10 to t equals to 15 is equals to this area, which is a rectangle with one side, this side is 5 and this side is 12. So you will have 5 times 12, which is 60 meters. So in the first 10 seconds, you traveled 80, and then from 10 seconds till 15 seconds, you traveled an additional 60 meters. So total distance traveled at t equals to 15 would be the 80 meters that you traveled in the first 10 seconds and the 60 meters that you traveled between 10 and 15 seconds. So you get 80 plus 60, which is 140 meters. So at 15 seconds here, you have traveled a total distance of 140, which should be in the middle here between 120 and 160. So now you have 2 points here. And then at time t equals to 0, you have traveled 0 distance. So your graph will start here and will end here. Now we have to determine what's the shape of the graph. So if you look at the speed time graph, which is, we know that the gradient of the distance time graph is the speed. So from t equals to 10 till t equals to 15, your speed is constant. It's not changing, right? So if the speed is constant, that means the gradient should be constant between 10 equals to t equals to 10 and 15. So what does a constant gradient mean? That means it's a straight line. So between t equals to 10 and t equals to 15, you will actually have a straight line like this. Uh, Wait, let me make sure I connect this here. Yeah. So you'll have a straight line between t equals to 10 and t equals to 15 because you have your speed is constant. So your gradient of this distance time graph would be constant as well. So that is given by this straight line. And you calculated the 2 points. At 10, you are at 80 meters. At 15, you are at 140 meters. So now this part is remaining. And we can look here that the speed is increasing between t equals to 0 and t equals to 10. That means that the gradient of your graph should be increasing as well. So what type of curve has an increasing gradient? So either this shape or this shape. So of these two, if this is your axis here and if this is your axis here, this is a decreasing gradient because it's the curve is going towards a horizontal line which has a zero gradient, while here you have a curve which has an increasing gradient. So you will be drawing this curve from t equals to 0 till t equals to 10. So it will be somewhat like this and then an increasing gradient. So you have a curve with an increasing gradient and then a straight line between 10 and 15 because you have your speed is increasing from 0 to 10, but then it's constant between 10 and 15. So this is how your distance time graph will look like for this question. Question number 23 is the diagram shows a sequence of triangles made up of identical sticks. Each triangle has two or more sticks on each edge than its previous triangle. The table shows information below. So you have triangles, number of sticks on each side, and number of sticks in the triangle. So you have to complete the column for triangle 4. So number of sticks on each side for triangle 4. So this is your stick. This is one stick. This is second. So this is one. This is the second stick. Third, fourth, fifth, sixth, seventh. So 7 sticks on each side for triangle 4. And number of sticks in the triangle would be 7 times 3 because you have 3 sides. So that would be 21. Find an expression in terms of n for x. So this is a question related to a sequence. So you have sequence here for x is 1. So x is basically the nth term of this sequence. So you have a sequence here which is 1, 3, 5. So every time you add 2 here to get the next value. So let's write down the sequence value. So 1, then you have 1 plus 2, which is 3, then 1 plus 2 plus 2, which is 5. So this is the first term, this is the second term, this is the third term. So your nth term would be nth term would be 1 plus 2 plus 2 plus some number of 2's. So you have to basically calculate how many times you add the 2. So if you look at this sequence here, in the second term you added 2 just once. In the third term you added 2 times. So you're basically, if you're looking at the nth term, you're adding n minus 1 2's. So your sequence will be 1 plus uh, 2 into n minus 1. So you will add n minus 1 2's to your nth term, because for third term you're adding 2 2's, for the second term you're adding 1 2, and for the first term you're adding 0 number of 2's. So this becomes, so now I can simplify this expression. So 1 plus 2n minus 2, and then this becomes 2n minus 1. So your your nth term, which is x, is represented by x equals to 2n minus 1. Part C is find an expression in terms of n for y. So for y, you are adding 6 to each previous value. But remember, when you calculated these values, you simply multiplied this value with 3 to get the values in this bottom row. So if you found the value of x, if you look at here, 7, you're multiplying by 3, you're 5, multiplying by 3 to get 15. So if you found x, you can multiply it by 3 to find the value of y. So y equals to 3 times x. So x is given by 3 into 2n minus 1, which is equals to 6n minus 3. You can also calculate using the same way by expanding the sequence, but this is quicker since you know the relation between x and y. You can simply multiply the expression for x by 3 to get the value of y. Part D is the total number of sticks in the first triangle are 3. Sticks in the first two triangles are 12. First three triangles are 27. Write down the total number of sticks in the first four triangle. So you know that for the first three triangles, the total number of sticks is 27. So 27 in the first three. And then if you add the number of sticks in the fourth triangle, number of sticks in fourth triangle is 21. So you get 48. So you had 27 sticks in the first three triangles total, and then you added the sticks in the fourth triangle to get the number of sticks in the first four triangles, which is 48. Uh, Part 2 is find an expression in terms of n for the total number of sticks in the first n triangles. So again, this is a sequence question. So let's first write down the sequence. So for the first triangle, you have 3. And then the first two triangles, you have 12 sticks. First three triangles, you have 27 sticks. First four triangles, you have 48 sticks here. So now if you see, the best way to get a grasp of these problems is to practice as many as possible. So if you look at these, if you look at the numbers in this sequence, 3, 12, 27, 48, I can see that I can take 3 common. So this becomes 1. If I take 3 out of 12, I get 4. 27 divided by 3 is 9. 48 divided by 3 would be 3 ones are 3, 1, 18, and 16. So now if you look at these terms, this is actually 1 squared, this is 2 squared, this is 3 squared, this is 4 squared. So the nth term will be n squared, and then you're also multiplying by 3 outside. So your expression for the number of sticks in the first n triangles would be 3n squared. So this is 3n squared. Let's move on to question number 24. So A is the point 5, 2. So this is represent A is 5, 2, and B is 9, 6. So this is 9, 6. AC is parallel to x-axis and CB is parallel to the y-axis. The equation of the line AB, this line here, is x minus y equals to c. Find the coordinates of C. So since this is parallel to x-axis, the x value will not change if you move, the y value will not change if you move from A to C, because your y value will remain this here. So the y value of C, the y coordinate of C would be the same as the y coordinate of A here. So the y coordinate of C would be 2. And since this is a vertical line, because it's parallel to y-axis, the x value remains the same throughout this line. So the x value of B would be the same as the x value of C, which is 9. So your coordinates of C are 9 and 2. The region inside the triangle ABC is defined by 3 inequalities. You have to write down these 3 inequalities. So this region here, which is inside this triangle ABC, so that means you have to represent this region by 3 inequalities, which are basically the equations of these 3 boundary lines. So if you look at line AC, this has, since this is parallel to the x-axis, this equation, the equation of this line is, so this is 2 here. So this is simply y equals to 2, this line here. This line here is at x equals to 9 because it is parallel to y-axis, so it's a vertical line. And this third line here is represented by this equation. So if you look at this line, y equals to 2, the region inside triangle ABC is above this line. So this is y greater than 2. And you'll not say greater than equal to 2 because the line is dotted. It is not part of the region. You're only looking at inside the region. So this line is x equals to 9. Since the region that we are interested in is on the left side of this line, so this becomes x is less than 9 to the left of this line. And for this line, x minus y equals to 3, the region is below. But let's first make y the subject of this equation and then write the inequality just to make sure we get it right. So x minus y equals to 3. So if I take y to the other side and bring 3 here, I get y equals to x minus 3. So since this region is below this line, so my inequality would be y is less than x minus 3. Now, if you didn't do that, if you didn't make y the subject of the equation and you simply wrote x minus y less than 3, that would have been incorrect because if you look at these two inequalities, this is the correct answer. And if you look at this, this is actually x minus 3. And then if I take y to the other side, I brought 3 to this side, this becomes y. So this is y greater than x minus 3, which is incorrect since we are looking at the region below this line. So my correct inequality is y is less than x minus 3. So it's always a good idea to make the y the subject of the equation before you substitute the equal sign with the inequality. Otherwise, like in this case, if you straight away substitute the sign, you will get the wrong answer. So always try to make the y the subject of the equation before putting in the inequality. So these are the three inequalities that represent this shaded region here. So let's move on to part B. The point AB, where A and B are integers, lies inside this triangle ABC. It also lies on the line y equals to 1 by 2x. Find the values of A and B. So you have to find the coordinates AB such that that point A and B are integers. So they are not decimal numbers. So it's a whole number, both A and B. And the coordinates lie inside this triangle ABC, and they also lie on this line y equals to 1 by 2x. So let me just quickly sketch the axes here so that we can solve this. So I'm only interested in this region, so I'll only draw these axes from, so my x value will start at 5 and go up till 9. So let's start here at 0. So my 5 would be at 0, 6, 7, 8, 9. So let me just mark them as well. So this point would be my 5, 6, 7, 8, and then 9. And then on the y-axis, I have to go from 2 till 6. So let me place my ruler here, rotate it at 90 degrees here. And then this would be, I can start from, so I have to draw from 2 till 6. So 2, 3, 4, 5, 6. So I have to go up till 4. So let me draw this from this side. So I have to go up till 4. So let me just quickly mark the points here as well. So this is my point, this is the other one, this and this. So this is my 5, 6, 7, 8, 9, and this is 2 on the y-axis, 3, 4, 5, 6. So this point here is A, which is right here. This point here is C, and this point up here is B. So my line AB is, oops, my line AB is represented by this. Let me draw line AB as well. So this is my line AB. And now if I look at the coordinates inside this shaded region, let me complete the grid here and oops. So if I draw the lines here which represent this grid here, then here, and then on the x-axis as well, the vertical lines of the grid. So this would be this, this, and this. So this is your grid, right? You can quickly sketch in a similar way using your ruler as well. So let's look at the integer coordinates that are inside this region. So you have this point here, this point here, this point here. So this is 6, 3, 6 on the x-axis and 3 on the y-axis. But if you look at all these 3 points, these are on the boundary line AB. So these are not part of the region. The only integer coordinates that are inside this, inside the shaded region, let me mark them in green. So this one, and this one. These are the only 3 coordinates which have both x and y coordinates that are integers. Otherwise, the other coordinates, all other coordinates here would be will have decimal values. So let's look at this first green point. The x coordinate is 7. The y coordinate is 3. Oops. Let me erase this. 1 second. So this is 7, 3. And then if you look at this point here, this is 8, 3. And if you look at this point here, this is 8, 4. So you have these 3 points that are inside the region. So your values of your point A, B is one of these 3. So these 3 lie in the region. Now you have to find the one which lies on the line 1 by 2x. If it lies on the line 1 by 2x, that means the value of y is half the value of x. So your y coordinate should be half the value of the x coordinate. So if you look at 7 and 3, 3 is not half of 7, 3 is also not half of 8, but 4 is exactly half of 8. So this will satisfy the equation. If your equation is y equals to 1 by 2x, and then you substitute x value here, which is 8, so you get y equals to 8 over 2, which is, oh sorry, yeah, 8 over 2, which is equals to 4, which is correct because your y coordinate here is 4. So your answer is the coordinate that you're looking for, the point that you're looking for is represented by 8, 4. Your x coordinate is 8 and your y coordinate is 4. So that's how you can quickly solve this by sketching a two scale, draw an axis, and you can represent each unit by 1 centimeter and quickly sketch the graph and look for the points that are inside the region. So this ends this paper, October, November 2016, paper 1, variant 1.